let's go through the correct answers to the quiz. I think there were a number of questions on here that tripped you up. There was one that actually tripped me up the first time I went through it. Thank you. Okay, Sarah, you pop a squat. Come on, hurry up. First question about brook trout. Look, what does domain mean?
X values.
X values, the set of all inputs. Okay, so let's look at what looks like a reasonable domain. Now, A is ridiculous because there's no such thing as a negative length trout. B and C I'll come back to. Letter D, for all of you who fish, I don't care how much you fish, you cannot catch a 2,000-inch trout. Okay? So letter D is out, even for the best of liars. Now we're looking at B and C. What's the difference between B and C? Go ahead.
B, it says it can be equal to 0.
That's right. And C, you cannot. Can you catch a 0-inch fish?
No.
Therefore, B is out. A lot of people put B as the answer. Let that be a lesson to you. What's happening is you looked at the first thing and jumped at it rather than considered to look a little further. I think if you would have considered C and B together, you would have found the difference. Okay? Next, number 2. I'm telling you, raise your hand if you got it right. Now look at all the people who didn't.
Oh, you got it right.
We said to you guys, you need to write this out and be very deliberate and careful about it. Take a look at my work. If you got it wrong, compare it to yours. There are way too many people getting this question wrong. This should be a slam dunk. Every kid in the room gets it right every single time question. Where is the breakdown? I don't know. Can you tell me? Anybody seeing a problem? Are you writing the minus and the whole package? Because when it says express A minus B, you have to subtract the whole of B. So all of B must go in a package or grouping symbol, a parenthesis. Any questions about number 2? Okay, now number 3 I gave everybody correct. But that's because it kind of got messed up a little bit at the top of the chart. It goes down about 80, then there's something in the middle of nowhere, and then it starts going down about 80s again. So it was supposed to be linear with a negative rate of change, but because it jumped all around in here, I just gave it to everybody. But understand that if the top 2 rows weren't there, I would be going down 80 every time, and it would be a linear with a negative rate of change. Okay? So this one is just messing things up. Now we get to the last one, and I actually got it wrong the first time through, as a lot of people did. My instinct was to put choice 3 because I saw 21,600, and then I saw a couple of people in a row put down choice 1 and get it wrong, and I said, wait a minute, let me look at this again. And I reread it, and it says, what is the profit? The profit is only what's above the 15,000. So I didn't catch that the first time through. Very good, those who did. You have to subtract it, 21,600 minus the 15,000 you started with. The profit is 6,600. Okay? Any other questions about the quiz? Okay, tomorrow's the 3rd in the series. Be prepared. Okay. This is to do it, isn't it? Yes. So let's go to last night's homework answers. We got to go a little quicker on this today because I want to make sure I get through all of today's lesson. But you can check out your answers. This first one is in millions. Raise your hand if you have any questions that you want to go over. I'm particularly concerned about how you begin, and B you have to go to the quadratic formula on. Sorry about that. I should have made it one that worked out better. But A and C, and I wasn't about to do it. I didn't have time. A and C work pretty straightforward. I want to make sure that on letter C you realize that you need to factor out the common x and that you did not lose track of it and only put -5/2 as your answer. That's the kind of mistake that was made on the last test by a lot of you guys. It's both 0 and -5/2. That's why I circled both of them. I want you to realize that. Okay, any questions? On the bottom there it says write an equation of a line perpendicular to. We haven't spent much time talking about this, and it's not, I don't believe it's part of the curriculum for this year, but It's worth mentioning because it's pretty easy. It's the same as the one above it. Parallel means they have the same slope. Perpendicular is a negative reciprocal slope. So I take the 2 and I make it negative 1/2. Okay? All right, we'll go to the next page. Our basic work with radicals here. We should be getting a little more comfortable with radicals. At this point in time, you know, I don't think it's a lot to say that we should be getting all of these right. If you're not, a little thing called extra help.
Are you having your show tomorrow?
Yeah. Yep, tonight at the library and Wednesday, Thursday tomorrow, and Thursday in the morning. Don't forget your relearn packets are due on the 30th. No excuses. Okay, I wouldn't go nuts trying to copy stuff down now. I think that's counterproductive. I think you should be comparing in your mind the answers to the answers that are on the screen. If you see something you did wrong, you want to write yourself a quick note, that is good. If you want to copy down how to do something, I don't think it's a good idea. I would rather see you do that at home. I think you're wasting your minds. Yes?
Is a binomial also considered a polynomial
Yes.
because it has more than one thing?
Yes.
That was weird.
Okay. When it comes to recursive notation, you have to have a sub 1, and then you could write either of these two formulas. Juliana likes to write it like this, so I added this in today so that she could see if she was right. And sometimes they put that as a choice, so you should be prepared for it. Okay? When you do explicit formulas, that's where you're looking at the n-1 stuff. Okay, remember domain is set of all inputs, range set of all outputs. To find the range, a great way to do it is to look at the graph and see what y values are covered, or look in the table. From a conceptual point of view, it's impossible to have 2 to any power ever be equal to 0. It could be a really, really tiny number, but it won't be 0. So then if I take 0 minus 3, it means it can't ever equal negative 3, which is why the range is greater than negative 3. Okay? Pretty fun? Sure. I find, personally, I find exponential functions hilarious. I go home, I pop into like the little YouTube videos all about exponential functions. It's just great. Okay, now, I'd like to have a pet lion one day. That'd be pretty cool.
Wow.
All right.
Large.
As far as the which one's bigger, at birth, the Great Dane puppy is a little bit bigger. If you look at the chart, these each work out to be 2. So 2, 4, 6, 8, 10, 12. And the lion is 8. So at birth, the Great Dane puppy is bigger. But when we get later at 32 months, which is almost 3 years, they look to be about the same. But if you look at the graph of the Great Dane puppy, it's hitting a limit. Whereas the lion graph looks to be continuing up by more or less the same amount. So I think the lion barely, but if you made an argument for equal, I could live with that argument too. Okay? All right. Now, if they gave that on the Regents, it would be a little more obvious. All right. Any questions? All right, I didn't do the rest of the homework. That's enough to get you started. Now let's take a look at the do it. Okay, and you'll notice that this is a piecewise linear graph. And you'll also notice that the topic for today is analyzing graphs. What we're going to do all period long is take a look at graphs, analyze them, have them make sense to us. So this is a piecewise linear graph where the graph changes direction in the middle, and it's made up of, obviously, two pieces. So, did I scan the wrong one in here? No, I didn't. I did the answers to these. You gotta be kidding me. How could this not get scanned? Well, let's try this again. Unless it's like invisible ink on here. I don't know what's going on. Come on. All right, this is looking much better now. Ready? Oh, here we go. All right, excellent. Very good. I don't know why this didn't pop up right the first time, but it didn't. Okay, so here's the graphs, and then it says write an equation for the first piece of graph and an equation for the second piece of graph. For the first piece of graph, I noticed that the y-intercept is 0. And then I do the slope formula to the 2 points that they gave me. I come up with 9. So that means that the correct equation for that line is y equals 9x, using y equals mx plus b.
Also, it's kind of obvious because if you divide by half, like if you got 11, it would be 1199.
That's a true statement.
And 99 times 2 is 198.
Okay, there you go. All right, now, next one. Letter B, what's the second piece of the graph? Now, this isn't so obvious because it doesn't have a y-intercept of 0. If you just extend this line and continue it down, you'll realize that that y-intercept is negative. So, I got a little work to do with this guy. First, I find the slope. It works out to be 135 over 10, which is 13.5x. Then I plug in either one of the coordinates. I chose this guy. And when I plug it into y equals mx plus b, the y is 630, the x is 60. I come out with b is negative 180. So then I put the negative 180 in. The slope I knew was 13.5. So I get y equals 13.5x minus 180. Okay? Any questions? All right. Now, domain restrictions. There are domain restrictions. If I write the function rule, the y or the output is, it's 9x for all x values between 0 and 40. But it's 13.5 times x minus 40 plus 360 if x is greater than 40. Now, where did I get all those points from? First off, the 13.5 x value doesn't start until after I get to 40. That's why a domain restriction is that it has to be greater than 40. And I have to subtract the first 40 hours to find how many hours are greater than 40. Like if you work 45 hours, I'm not going to do 13.5 times 40 because for the first 40 hours, you're only getting paid $9 an hour. It's only after 48 hours or 40 hours that the slope increases or your rate of pay increases. And then you have to add in the 360, which is here, that you would have made working 40 hours at $9 an hour. So that's where all of those numbers come from on there. So there's a restriction from 0 to 40. At 40, you start getting paid more. The slope changes. And there's a restriction on this that it only works for when it's greater than 40. Okay? Explain the domain in the what of the problem? What does that say? Context. Okay. Well, the context is time and a half. I don't know if any of your parents work a job where they get paid by the hour. My dad used to do that for the railroad. And on the railroad, if you worked past 40 hours, you got time and a half, which is, you get half again more, and that's why it goes from 9, half of 9 is 4.5, 9 plus 4.5 is 13.50. That's what's happening here. You get past 40 hours, you get time and a half. That's a federal law. But for the railroad that my dad worked for on holidays and weekends, on holidays, I'm sorry, he would get double time and a half. So if he normally made $40 an hour on holidays, he'd make $100 an hour. So we had this standing rule that he worked every holiday, all the time, because he could make so much more money. Yeah.
No, just stretching.
Okay, sorry. It's a pass if you want to do it. Okay. Now, next up, today's lesson, we just did the do it, and all we're all about today is the graph. And we're just going to talk about graphs and recognize graphs and see what's going on with graphs and so on and so forth. Okay? So, what's the parent function of this particular graph?
X. Y equals
Function
M X.
y equals, well, m, and what's the slope of this?
1.
1. So it's y equals 1x or y equals x. That is the parent function, okay? Now, I didn't do anything to this graph yet, so it's just still going to be y is equal to x. But what if I did something? What if I took the graph and I simply did this?
You gotta press the projection button again.
I did. Why is it? Oh, no. Battery might be dead. Yep, I think the battery's dead. I'm not getting a little green light. But I have an extra battery, so it's not the end of the world. I started noticing it flickering the other day a little bit. Good. So I think we should be ready to rock. Good. Okay. So what if I just slid the graph up to here? Now what's the equation? Go ahead.
Wouldn't it be y equals x plus 2?
That's right. And let's look at it two ways. Let's look at it from the point of view of it has a y-intercept of 2. Okay, since it has a y-intercept of 2, I just have to include that b is 2. Or I could look at this as what it is, which is horizontal shift. I'm sorry, vertical shift. So this is y equals x, the parent function, and I've moved it up 2. And we know that if we just put a plus or minus whatever, according to how we moved it, that would tell us a vertical shift, and I just add that to the end of the problem. Yes?
But didn't it also shift over a little bit? Or did it only go, because like, I don't know if when it went up, it also shifted. You see how it's not like right in the same.
Oh, with a linear, we don't have to worry about that, because there's no vertex or turning point.
Okay.
Okay. Now, next one. What is the parent function of the next one, everybody? Remember, this is sight recognition. Remember we talked about sight recognition with words? We have to have it with graphs. What is this graph?
Y is absolute value.
That's right, y equals the absolute value of x. What if I took this graph and moved it down to here? What would that now be?
Y equals absolute value of x minus 5.
That's right, y equals absolute x minus 5, because I've done a vertical shift of down 5. What if I move it over to here?
Y equals absolute value of x plus 3 with the in the
In the parentheses, right, and we reverse it because it's in the grouping symbol. Okay? Questions? Preguntas? Rulin, you awake?
Heck no.
You don't look awake. You sure you're okay? All right. All right, now, what is this the graph of? It is 2 to the x. How can you tell it's 2 to the x and not something else?
Oh,
Go ahead.
well, one way you can tell is that it keeps on going up, like it's keeping going up. Like
Well, that gives you the
And-
exponential part, but how do I know it's 2 and not 3 or 4 or 5?
And the other reason why you know why is because the y value for x equals 1 is 2.
That's exactly right. It's the point 1 comma 2. So it has to be 2 to the x because 2 to the 1 is 2. If it went through 1 comma 5, then it would be 5 to the x. Okay? All right. By the way, if I took this graph and I slid it up to here, right, what would that then be? That would be y equals 2 to the x, and everything is sliding up 1, so I would be adding 1 to it. Okay, so you can do vertical shift and horizontal shift to an exponential graph. All right, what's the parent function here? Everybody should recognize it. Y equals x squared. Good. What would it be if I moved the graph over to here? And let's forget the narrowness. Let's just pretend it's perfectly right. I just drew that sloppy. What would that graph be? Y equals what?
Squared plus 2.
Or minus.
I honestly didn't hear what you said. What would it be, guys?
Y equals
Y
x
equals
squared
x
minus.
squared
Be x minus 3 squared, then what?
plus 2
Minus 2.
minus 2.
Yeah, vertical shift is always the same. This is the point, negative 3, pardon me, positive 3, negative 2.
Oh, okay.
So I reverse it in the parentheses and I keep it the same for the vertical shift at the end.
I thought it was
Okay?
-3, -3, or 3, -3.
No, it's negative 2, but even if you went with negative 3, I think you said positive before.
Okay.
All right, that was the big mistake there. All right, let's take a look at
Then,
what's this graph, looking at it and remembering it.
oh,
AJ?
Square root of x.
That's right. So this would be y equals square root of x. And what if I took this graph and moved it over to here? What would that be? Come on, head in the game. What would it be here? Y equals what?
Y equals square root of x minus 4.
Yeah, and I would want to make sure that that minus 4 is under the radical. What if I did this?
Y equals
Makes
square root of
pretend
x-
it's perfectly good. Y equals what?
Y equals square root of x minus 4.
Minus 4. Okay, good. Right, because I did a vertical shift of down 4. 1, 2, 3, 4. So since I went down 4, I had to include the negative 4 at the end. Okay, next sight recognition. What's that graph?
X
oh,
cubed.
cube it.
Y equals x cubed. Good.
The reason why you can put it's cubed is because unlike the even ones, it's not going down then back up. It's just going up. then
That's right. In other words, since it's a negative, since the exponent's odd, you can't get a negative sign. Now, what if I did this?
Are those called sectors? Different parts of the graph?
Quadrants.
Quadrants. Okay. I was trying to figure out
What would we get there?
Q plus 3.
What would that graph be? I know you know. Let me give somebody else a shot here. I know Janelle and AJ know. Somebody else who hasn't helped me yet.
Kyle.
Somebody who hasn't helped me yet. Miss Ford. I should just call you Chevy. Go ahead.
Chevy. My God.
What do we get? Nothing? What? What did I do to the blue graph to make it the green graph? Moved it up. What kind of shift is that? It is positive. Is it horizontal or vertical? Vertical. So where does the vertical shift go? Does it go in here in a grouping symbol or does it go at the end? Good. Nobody watching is going to be able to hear a word you're saying. Or nobody listening, I should say. So how many did I move up? Good. So it's y equals x cubed plus 3. Okay, any questions? Okay, let's take a look at the next one, a little sight recognition. What is that graph? Spencer.
Cube root of x.
Y equals cube root of x. Very good. Oh. Y equals cube root of x. And what if I moved it to there? Now what would I have? What would we get if I moved it over to there? Somebody else help me. Somebody else help me. Somebody who hasn't helped me yet. Anthony.
Cube root of x minus 2.
That's right, cube root of x minus 2. In the grouping symbol, because I moved 2 to the right, you need to reverse it. Any questions? Okay, so what we did today was sight recognition on graphs, reminded you of each of them. Reminded you of horizontal and vertical shift, and learned it also applies to exponential graphs. Hasta la vista. Every calculator gets put back. Don't leave any over there.
Catherine Gonzalez, United. Catherine Gonzalez, United.